Hello everyone, welcome back to the course Introduction to Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. This is the fourth lecture in week 4 where we will discuss about budget programming. My name is Chirag Kothari. I am an assistant professor in the Department of Civil Engineering. In the last lecture, we discussed budget planning as well as we briefly talked about budget programming. We saw that budget planning aims to estimate the financial resources that are required to maintain our assets. The goal of budget planning was needs assessment, and we were trying to estimate the minimum budget or the amount of rupees required to maintain all our assets. Conversely, the process of budget programming was focused on allocating budget. We had discussed that in case of budget programming, we will evaluate various allocation alternatives so that we can optimize the overall infrastructure condition, at the same time ensure that we are within the budget. So, budget planning was focused on estimating how much rupees is required. Budget programming is focused on allocating those rupees. Once you have a budget, you try to decide how to allocate this budget. I ended our last lecture where I talked about 4 different methods to do it. We saw that budget programming can be done using subjective experience, decision metrics, decision trees, and optimization. In this lecture, I will be going over these methods in detail. We will discuss how to conduct budget programming. Before we start discussing about budget programming, it is important to understand that we are doing network level decision making and not project level decision making. Let us briefly discuss what is network level decision making. Network level decision making is different from project level decision making. In case of infrastructure management, we have to take both types of decision. Some decisions are at the level of network, while others are at the project level. In case of network, we are looking at a group of projects. So, here instead of one project, we are focusing holistically on a group of projects. We also try to understand what are the goals for the entire network. We try to understand the constraints and finally decide relevant projects. So, here in the case of network level programming, we have say 100 projects under considerations. We have some goals, objective 1 and 2 say. We have some constraints C1 and C2. We basically utilize this information to identify potentially candidate projects, say around 20 projects out of 100. So, this is network level programming. On the other hand, project level programming is focused on a given project. Once we have identified a candidate project, we try to get into details of that project. We try to understand how we can maximize project performance and its life. Here the focus is on one particular project or the selected project. The level of decision making is quite detailed at the project level. To summarize, network level management is focused on a group of projects where the purpose is to develop a priority program. A priority program includes list of candidate projects. Here we try to achieve network goals while utilizing the available budget. In case of network level management, since we are focusing on a group of projects, the data requirements are less detailed. This is a more holistic information or holistic planning, where in case of network level management, data requirements are less detailed. On the other hand, in case of project level management, we are focusing on a specific project. The purpose is to identify appropriate M&R strategy for the asset under consideration. We incorporate different characteristics, features and information here. Data requirements are much more detailed in case of project level. So, I hope this distinction is clear, where in case of network level management, we are focusing on a group of projects. On the other hand, we are dealing with a specific project. This is more detailed decision making, where you need a lot more information to determine what is best suited for a project. On the other hand, in case of network level management, we are doing prioritization to identify what are the candidate projects. So, output of network level management is candidate projects. What are the projects that require maintenance and rehabilitation? To summarize, budget programming deals with network level management. Here, we are trying to estimate what are the projects which are suitable for maintenance and rehabilitation. We are trying to identify all the candidate projects. The goal of budget programming is to move away from subjective decision making to a more objective decision making. At the same time, we want to identify projects at the right time. So, instead of doing reactive decision making, we want to do proactive decision making. For example, you might want to select a project before it has deteriorated a lot. You do not want to do corrective measure, you just want to do preventive measure. So, you want to move towards proactive decision making. At the same time, within budget programming, we try to emphasize on long term planning. Instead of short term planning, we acknowledge that every asset has a long life. So, it is important to account for long term decision making rather than short term decision making. Finally, we want to come up with a program which is not just optimal, but robust, resilient as well as sustainable. I understand I have discussed a lot of words here, but in the subsequent lectures, we will get into details of what is resilient, what is sustainable, what is optimal and so on. For now, let us understand that budget programming is a procedure to identify relevant candidate projects. Now, we will get into details of how to select candidate projects. Methods for selecting candidate projects are as follows. It could be done either using subjective experience, that is, we rely on the experience of the user or the agency who is maintaining the asset, or we could utilize a decision matrix. Another alternative is to use a decision tree, and we can also utilize optimization. Each of these methods are basically based on the performance criteria. This may or may not involve economics at this stage. Performance criteria basically means we are taking a decision based on the relevant performance parameter. For example, in case of road, we can have a parameter for level of service, or alternatively for the roads we can have something like condition score. Alternatively, for a building we can have a performance parameter like safety and so on. So, there are different performance criteria which are possible. We will talk about them sometime later, but for now let us understand that the process of selecting candidate projects is a function of the performance criteria we have in mind. We utilize subjective experience or some of the other methods like decision tree, decision matrix or optimization to basically do a prioritization based on the performance criteria. Let us talk about them in detail. The first method is subjective experience. In this particular case, ranking of projects is done using subjective judgment. This is a simple ranking by experienced professionals. Subjective judgment or subjective experience allows for human judgment in decision making. However, it can get really difficult if we have a large set of projects. If the decision makers are required to take a decision for a small set of projects, then probably subjective experience is fine. However, if you have a large set of projects, then it becomes difficult for humans to use subjective experience without introducing biasness or recency. Let us discuss different pros and cons of using subjective experience. First of all, it is easy to understand because the subjective judgment will explain why we have selected one project over another. Experts will take a note of why a given project is important. It is simple and it is also quick. However, there are several cons associated with using subjective experience. First is, it might be far away from an optimal decision. Since we have a lot of projects, if we don't do a data-driven decision making, then there is a risk that whatever judgment or decision we have taken, that might not be optimal. Also, since humans are bound to make errors, the decision making might be inconsistent. Also, it is subject to bias. We can have recency bias, decision fatigue, and so on. Having said that, still there is value in using subjective experience or subjective judgment in some cases. Subjective decision making or subjective judgments are often utilized together with objective decision making. Subjective experience in decision making helps us in understanding stakeholder preferences. Since any infrastructure has multiple stakeholders, each of them can have their own perspectives, prioritizations. Since an infrastructure has multiple stakeholders, each of them can have their own perspectives. They can have their own priorities, and a given department might have their own learnings. So, it becomes important that we incorporate subjective experience along with objective decision making. Further, oftentimes there are some objective data sets which are incomplete or ambiguous. In such cases, we have no other option, but we have to rely on expert judgment or intuition. If we do not have relevant data sets available for decision making, then we rely on past experience as well as subject knowledge of the experts to take a decision. Also, oftentimes in decision making, there are some qualitative criteria. For example, strategic fit, whether a project is urgent or a project has a potential for innovation, and so on. All these criteria are qualitative criteria. It is difficult to assess them objectively. So, again we have to rely on subjective experience to basically quantify these. So, what I am trying to say here is, it is difficult to say objectively whether a given project has potential for innovation. We have only one option. We have to rely on subject matter experts for their discretion. They should identify whether a given project has potential for innovation or not. Similarly, strategic fit could be another qualitative criteria. So, if there are evaluation factors where it is difficult to incorporate them objectively or it is difficult to quantify them, then we have to rely on subjective experience in decision making. So, we discussed that subjective experience plays an important role in decision making, but in real practice, oftentimes it is combined with objective ways of selecting projects. Let us discuss some of the objective ways of selecting candidate projects. One such method is decision metrics. Decision metrics is used to identify candidate projects based on relevant parameters. For example, level of service can be one of the parameter. Now, let us see how does a decision matrix look like. A decision matrix looks something like this. You see here that we have two axes. First, we have current condition and we have the deterioration rate. For deterioration rate, we have two categorizations here. Either it can be low or it can be high. On the other hand, for current condition, again we have two criteria here, low and high. So, in case of a decision matrix, what we are trying to say is we will identify all projects which have a low current condition and a low deterioration rate. At the same time, we will find projects which have a low current condition and high deterioration rate, and so on. Then once we have done this categorization, we can identify priorities for these projects. For example, any project which has a low current condition, that is the initial condition is low and it has a higher deterioration rate, it means that it is a critical project. So, it must be given priority 1. So, this is the highest priority, because what we are saying is the asset under consideration has a low condition. So, in this particular chart, the performance is low. At the same time, the deterioration rate is also high. So, this particular infrastructure becomes critical. So, it has the highest priority. On the other hand, any infrastructure which has a very high condition and it has a slower deterioration rate, then it has priority 4. This is the least important for us because it has a higher condition and a lower deterioration rate. The other two cases where the current condition is low but deterioration is low, and the fourth case where the current condition is high as well as the deterioration is high, we can decide whether to assign priority 2 to this or priority 2 to the other one. As well as this can have similar priorities. This is where subjective experience comes into picture. The decision makers can take a call to assign priorities to such cases. They can decide whether case 1, low condition score and low deterioration rate, is more important, or the other case of high condition score and high deterioration rate is important. So, priorities between these two involves some kind of decision making from experts. Now, I hope the concept here is clear that once we have a list of projects, we try to assess their initial condition and their deterioration rate. Based on that, we try to fit all these projects in the form of this particular matrix. Say we have 100 projects in our portfolio and we want to use decision matrix to identify candidate projects which require maintenance and rehabilitation. The way to do it will look something like this. First, you start with all your 100 projects. You try to identify the initial current condition as well as deterioration rate. Then, using past experience, we need to define what is a low current condition. For example, one could say that if the condition is measured on a scale of 1 to 100, anything below 50 is low and anything greater than or equals to 50 means high. So, we first need to define these scales. Here, instead of having 2 categorizations, we could even have 3 or 4 categorizations. We could say condition score less than 30 is low, 30 to 60 is medium and greater than 60 is high. For now, let us just stick to 2 categorizations. Similar to current condition, even for deterioration rate, we need to understand what is a high deterioration rate or a low deterioration rate. So, someone could say that a delta change in performance over time less than 5 means the deterioration rate is low. or someone could say a delta change in performance every year greater than or equals to 5 is high. So, for all these 100 projects, we try to estimate the current condition and the prioritization rate. Then we list all the projects which have a low condition and a low deterioration rate, and we put them in this particular cell here. So, project 1, project 3, project 4 and so on. At the same time, we try to understand what are those projects which have a low performance but a high deterioration rate, maybe project 2, project 6, project 8 and so on. We try to assign all the projects in this particular matrix. Now, basically we overlap these two metrics and say that priority 1 should be all these projects which have a low current condition and a higher deterioration rate. At the same time, we say that all the projects which are listed in this particular cell have the least priority. This is priority 4 because all these projects have a high current condition and a low deterioration rate. I hope how to utilize decision metrics for project prioritization is clear. Let us discuss the pros and cons of using decision metrics. First of all, when compared to subjective experience, it is closer to optimal because now you have a more objective way of taking decision. This is also reasonably simple. It is not difficult to understand the current condition and deterioration rate. Also, utilizing a decision matrix is reasonably simple. Cons include this particular method cannot handle multiple parameters together. For example, in this case, we only have two parameters. One is current condition, second is deterioration rate. Now, one could argue there is a third parameter which is important and we should include that as well. Then we can use a decision matrix which is in the third dimension to include the third parameter. However, any more parameters, if they are required to be included, will make this process more and more complex. We will lose the simplicity. Further, there is no mechanism to rank projects within a given priority. For example, all the projects which are in this particular category, we do not have any mechanism to rank them within this particular criteria. For example, say we do project prioritization using decision metrics and identify 20 projects here. However, we only have money to execute 10 projects. Then it becomes difficult to find a way to rank within these 20 projects. We might have to create another decision matrix to do that. So, I hope this concept is clear that decision matrix is a simple and a powerful method to prioritize projects. However, it is difficult to include multiple parameters in the decision making. Having discussed subjective experience and utilization of decision metrics, let us move on to another method which is decision trees. We saw that in case of decision metrics, one limitation is it cannot account for multiple parameters in decision. A decision tree looks something like this. In case of decision metrics, the ranking is done based on parameters. For example, the first parameter here I have is whether the condition is greater than the level of service required. We are trying to assess current condition with respect to level of service. Either it can be yes or no. If the condition is greater than the level of service, we have the second criteria here. where we are checking deterioration, whether the deterioration is high or the deterioration is low. Based on the information, we finally decide what is an appropriate rank for this particular project. Also, we try to understand what is an appropriate maintenance technique for this particular project. Here, for simplicity, I have only included 2 levels of decision making. However, a decision tree can have multiple such parameters. We can keep on extending the number of decision criterias or parameters. Here, what we are trying to say is that for a given project, we will assess whether the condition is greater than level of service. If the answer is no, we will try to estimate what is the level of deterioration. If the level of deterioration is high, then this becomes a rank 1 project because it has a high deterioration as well as the current condition is lower than the level of service required. We could also decide an appropriate maintenance technique for this. We can say that we should do MNR technique 3 for this. On the other hand, we could say that for projects which have a condition score greater than level of service and have a low deterioration rate, we should probably use maintenance and rehabilitation technique 1 or do nothing. Alternatively, for projects which have a higher deterioration but the current condition is greater than level of service, we can use maintenance and rehabilitation technique 4. Here we could say MNR technique 2. So, decision trees, unlike decision metrics, have a flexibility to include a lot more parameters. Here, the way we are using this for a 2 cross 2 decision, it gives us an impression that decision metrics and decision trees are similar. However, in case of trees, we are allowed to include multiple branches. We can include a lot more decision making criteria. At the same time, we can decide to have more than 2 or 3 branches for each decision and so on. Let us discuss what are the pros and cons of using decision tree. First of all, decision trees can handle multiple parameters. Again, they are closer to optimal, objective. However, they are not so simple to develop. They are easy to use, however, it is difficult to develop them. It becomes tricky to decide which criteria should be given higher importance, what should be on the top of the tree, how should the tree flow from one criteria to another criteria, and so on. So, utilizing a decision tree is straightforward and easy, but developing a decision tree is complex. Moreover, similar to decision metrics, even in case of decision tree, the effect of timing is not considered. If you see here, in all these methods, we are just relying on the performance criteria. We are deciding which projects to prioritize based on the criteria. We are not keeping timing into the picture. That is, we are not deciding what will happen if I do a maintenance after 3 years versus I do a maintenance today, and so on. Right now, we are just trying to identify projects where timing is not considered. At the same time, economics is also not considered. The entire decision making is only focused on performance criteria. In summary, a decision tree or a decision matrix is useful because we have predefined criteria for decision making. A decision tree or a decision matrix basically utilizes predefined criteria, and this is an important aspect. That is, without even seeing the list of potential projects, we first define some criteria. These are clear and measurable criteria, and we use that for decision making. So, that way we have low biases. We are not biasing our decision based on the list of projects. We are defining the criterias beforehand. Moreover, this method is providing us with a way to incorporate expert judgment, their experience in a structured manner. All the stakeholders are collectively deciding the relevant performance criteria. So, decision trees and decision metrics are useful. However, they are difficult to implement, especially when there are several criteria. What happens if we have 4 or 5 conflicting criterias? Also, the weightage of different criterias is different. Then how do we take a decision? That is where using decision tree or decision metrics becomes difficult, and we have to move towards a method known as multi-criteria decision making, MCDM. I will talk about MCDM in the next week. For now, let us understand that whenever we have relatively less criteria for the decision, and when we do not have to account for timing or economics into the decision, we can use decision trees or decision metrics. Another method in addition to decision trees and decision metrics is a very popular method known as optimization. Optimization is a commonly used selection method for budget programming. In case of optimization, we utilize mathematical models and advanced analytical techniques to identify an optimal set of projects. These projects are selected in such a manner that they maximize the value and adhere to constraints. Any optimization model typically has some objectives. Typical objectives in case of infrastructure decision making are either we try to maximize benefits or we try to minimize cost. So, in case of optimization, either we try to maximize benefits. One could say, I will try to maximize the average network condition score, or one could say, I will try to minimize the life cycle cost for a infrastructure. One could argue, I will try to maximize safety, or I will try to minimize accidents. So, any objective function can have several options like these. Now, we try to select a pool of projects such that we maximize the benefits or minimize the costs, but at the same time adhere to constraints. One of the major constraints in decision making is the available budget. Additionally, in case of optimization, there are several other considerations. We need to first understand the planning horizon. For how many years are we planning? We need to understand how many projects we have. What are the set of treatment options available? What are the current condition of these projects? The deterioration rate, the expected level of service, available budget. What are the expected gains from each treatment? Any other constraints like uncertainties, user costs, social costs, so on. Optimization provides us with a mechanism to incorporate all these considerations into decision making. We will discuss in detail what is optimization and how to set up an optimization method for infrastructure decision making in the next lectures. For now, let us understand that in addition to decision trees, decision metrics, optimization is another method which can be used to identify candidate projects. Depending on the type of considerations we can have an optimization model which is a single objective model. That is, we only have one objective. Alternatively, we can have a multi-objective model where I try to say that I want to maximize average network condition, at the same time I want to minimize the impact on environment. So, now you can have a multi-objective optimization model. You can include more objectives here. Moreover, you can have a single constraint, for example, budget, or you can have multiple constraints. You can say that the optimization model should identify projects in such a manner that the condition score for any given project does not go below a number which is, say, the critical limit. Alternatively, we can have a single year plan and we try to optimize the projects, or we can have a multi-year plan. We can have an optimization model set up for deciding projects for next 10 years. Finally, we can also create a comprehensive optimization model which tries to identify which projects, when to do the maintenance and what to do, and at the same time it can account for the budget available, the goals, the policies and so on. In summary, optimization is a powerful tool which provides us a lot of flexibility in deciding how we want to prioritize our projects. In this particular lecture, we have only seen how to prioritize projects based on their performance. In case of optimization, it allows us the flexibility to include economic considerations into the decision making. It also allows us to include uncertainties into decision making. Moreover, we can also include multiple objectives into the decision making. So, in this particular lecture, we have seen how to utilize subjective experience or a decision matrix, a decision tree or optimization for selecting candidate projects. All these methods are focused on performance criteria. These methods may or may not involve economics. However, as we have discussed throughout the course, money is an important aspect in the decision making. A lot of infrastructure decision making is done keeping in account how much budget is available. So, the question is how to include economics into the decision making. There are some methods to utilize economics together with these methods to finally identify suitable candidate projects. One such method which we discussed was in optimization, we can have a constraint around budget. We also saw that in case of decision trees or decision metrics, depending on the budget available, we can decide which projects should be ranked 1 as far as priority is concerned. Now, let us briefly discuss how do we structurally and systematically account for economics in the decision making. How to include economics in decision making. This will be our focus in the first lecture of the next week, where we will discuss how to determine candidate projects under budget constraints. We will talk about methods such as cost benefit analysis. We will also talk about the concept of life cycle costing. This was briefly discussed in the first week. Now, we will see how do we utilize concepts of net present value and internal rate of return to do a life cycle costing for an asset. We will also talk about payback period. So, in this particular lecture, we briefly talked about different methods to do budget programming, especially when we are keeping the performance criteria in mind. In the next lecture, we will talk about including economics into the decision making. With that, I want to summarize what we have covered in this particular week. This particular week focused on extending the infrastructure management framework, which we started in week 3. Week 3 was focused on covering different aspects of data collection. In this particular week, we moved to performance modeling. We talked about how do we model performance for an infrastructure project. Then we moved towards understanding how to develop different alternatives. We talked about maintenance and maintenance strategies. Then we started our discussion around decision making. Within that, we talked about the fact that it is important to account for budget in decision making. Within budget, we discussed the difference between budget planning and budget programming. Now, the next particular set of lectures will focus on more details of how do we do decision making. We will try to understand the finer details of how to take a decision, and within that we will discuss how to include economics into the decision making. We will also discuss how to conduct multi-criteria decision making, and we will talk about how to do multi-objective optimization. So, in this week I have just touched upon some methods for doing budget programming. Now, in the subsequent lectures, we will go into details and talk about how do we do a multi-objective, multi-criteria economic decision making for infrastructure projects. Finally, briefly we will discuss the role of implementation and monitoring into this entire framework. With that, I want to end the lectures for this week here. Now, students are encouraged to go over these references if you want to learn about this particular topic. I hope all of you are enjoying the lectures. Thank you. Thanks for listening.